In this video, I'm going to show you how to add squid reduced data to a sample. So uranium-lead SIMS data from a shrimp, you can add those two data points. Here we've got granite S2, we're going to add some data to that. To be able to do that, you have to become a data contributor, and there's a video related to that. Go to the My Data tab, and in the menu, you select on the left UPB SIMS data. From your SQUID reduced data set, you'll export either a built-in report, a table for the unknowns, or the AGN-AusGeochem export table, which includes an extra couple of fields from concentrations and metadata on your common lead correction. This template will be available through Cerdals, and you can download it there. Create CSV, go back to AusGeochem, and either drag and drop or select the SQUID file there. So we select this SQUID output file. You'll see it imports 45 spots. At times there can be orange bars here as well. You just click proceed. Give this a name. Granite S2 session 1 package in this SIMS test package. S2 sample and amount. Mineral zircon was analyzed. You can add extra notes to that session. Information about the mount is added in the wizard step 2. And add the IGSN if that's minted, the coating, image characterization. Now in step 3, you'll be asked to provide some information about the data reduction software for reproducibility, and there's a few prefix values that you can edit if you need to. So they are the 238-235 uranium ratio and their decay constants and the calibration exponent. Click next and you get to the calibration information, where you can select from reference materials that we've included in the database. Select one of those. If you miss them, you can select others and send us a message. We'll add those reference materials. Calibration uncertainty. If you don't know where to find that, it's under the interpretations tab in the SQUID project, reference materials, and then calibration constant. All these errors are reported in 1 sigma, and here the percent level as a percentage. So 0.49. Then the reproducibility was 1.45%. You can see here, spot to spot error. These were included in the age calculations. Now, if you've also applied an instrumental mass fractionation factor on the 207, 206, then you can add information there as well. Click next. You'll be able to select the spots you want to associate to that sample. And I'd like to associate all the spots. They're from the same sample. But these are reference materials, secondary reference materials against which we can test the quality of the run, grouping them, having a weighted mean on that group of analyses and comparing it to the published values gives us an idea of how good that run was. Okay, click Save. And then we can go and view that on the map. See how the user interface displays a sample which has some data associated with it. Now, the package selected is correct. It's currently still teal colored, and there you go. It goes into yellow when it has data associated with it. Data is loading. It's a little bit larger because I want to have a look at the plots from the individual spot analyses. So here's some sample information, hand sample, some information about the age. We have not filled that out yet because we have not calculated a weighted age on a particularly interpretation of a couple of points together. Now here you can see the Terra-Wasserberg plot, nicely plotting those ratios on the diagram, the calculated ages versus the thorium-uranium ratio, and you can even plot the kernel density diagram here with an age peak of 645. Okay, thank you guys. If there's any questions, let us know.